need to teach you here, page 88, because basically this is just more to do with ionic reactions, yes? Now, instead of single replacement, they are, or sorry, instead of double replacement, they are single replacement. I said that backwards, sorry. So what you should know is that if you have an aqueous substance, what do you do with it? Tell your partner, what do you do with aqueous ionic compounds? What do we do? When we're writing an ionic equation, we split up the ions. What do we do if we have a solid or if we have a liquid? Leave it alone. It's page 78. 88, sorry, 88. So there's not much more to it than this. Yes? So that's about it. So that takes care of the single replacement. And I think what we'll do is we'll just kind of do a brief overview of neutralization, and then I'm going to let you practice ionic reactions, double and single, and neutralization. Yes? Because today's a short class anyway. You can get caught up on any of the dilution stuff also if you want to, and then next week we'll start our new things. All right, neutralization is on page 91. Now, these ones are going to require you to remember your strong acids. Oh, do you remember your strong acids? Tell your partner, write them down, do something so that you're not going to forget them. So I brought no clean clothes. The SO is SO4. The I is just I. The BR is just BR. The N is NO3. CL is just CL. And CLO is 4. Okay. How many H's go with each of these? How many H's with SO4? 2. How about all the rest of them? 1. And if you don't like that, you can do, who's going to remind you? Chloe. Whoops. Clyberson. Okay, same H's. Yes? All right. So now that you remember those, what is special about strong acids? How are they different from weak acids? Yes? Pardon me? Oh, yeah, sorry. 4. Yes? When they dissolve what? Yes, they dissolve in water. They don't dissolve into ions, they dissociate into ions. So there's 100% dissociation. How is that different from weak acids? Only a small portion dissociates. Mostly undissociated. So when it comes to writing our ionic equations, you are going to separate strong acids, but weak acids you will leave together. Okay? So let's add that in on here. Okay, these guys. Your strong acids split apart. Now, there is one little extra thing to remember, and that is that when H2SO4 comes apart, it dissociates not into 2H plus and SO4 minus, it dissociates into 1H plus and an HSO4 minus. Okay? There is a second dissociation. That's what we call our first dissociation, but the second dissociation is weak. The first dissociation is strong, it's 100%. The second dissociation, HSO4 minus, goes to H plus SO4 2 minus. This is weak. So when H2SO4 dissociates, you have tons of this, tons of this, and you have very little of the H plus and the SO4 minus. So basically, and we have none of this. So who are you going to write? Who are the important species? The H plus and the SO4 minus. And you're going to not write H2SO4, you're going to not write H plus, and you're not, or the second H plus, and you're not going to write SO4 2 minus. And if that confuses you, don't worry about it. I will probably avoid putting that on your test this year because we come back to acids in grade 12 and I'll ram it through your brain at that point. Yes? So if you're like, H2SO4, blah, I'll probably just use the other strong acids just to be kind to you. Or will I? Ooh, there's always that part of my brain that's like, yes, but it would be a challenge for the people who, like, you know, are going above and beyond. Anyway, we'll think about it. Okay, I've got a week and a half to decide, so we'll get back to you on that. All right. Things to remember. Calcium, strontium, and barium are actually considered somewhat soluble despite being listed as low solubility on your table. Assume that if I am giving you, if I say CaOH aqueous that we made a solution of CaOH2, or sorry, so that should be CaOH2 aqueous, and that it splits apart. Yes, if I say aqueous, you say, okay, Ms. Spence, it's aqueous. Unless it's in the answer key and you think it's wrong, in which case you can come and say, is your answer key wrong? But when it's in the reactants, like let's say number, did I put any in? Yeah, say here, assume that the CaOH2 comes apart. Yes, because it is aqueous. Don't be second guessing and looking it up and saying, oh, it's not soluble. Your chart says it's not soluble because 0.1 moles will not dissolve in 1 liter, but perhaps we've only made a 0.01 molar solution, in which case, yes, it does all dissociate. Is good? Okay. Yeah, so when it comes to these guys, do we want to do one together? Yes, okay. So let's do one together. We're going to predict our products, outside ions, inside ions. So we end up with KNO3. And all alkali salts are soluble, all nitrate salts are soluble, so that is aqueous. And then we have HOH, which is, of course, water. And now to write the complete ionic equation, we take all of our aqueous ionic compounds and split them apart. So KOH is an aqueous ionic compound, so we're going to split it apart into K plus aqueous plus OH minus aqueous. Now we have an acid. What do you have to ask yourself when you come to an acid? Is it strong or is it weak? HNO3, is it strong or is it weak? It's strong, so we're going to split it apart. H plus aqueous plus NO3 minus aqueous goes to, now we have an aqueous ionic compound, so that splits apart K plus aqueous plus NO3 minus aqueous. What do we do with liquids? Leave them alone. H2O, liquid. Do we have any spectator ions? We have K plus, which does not change. And if you were away yesterday, we call them spectator ions because although they are present, they don't participate, just like spectators at a sporting event, okay? So we have K plus, and who else does not participate in the reaction? NO3. So those are our spectator ions. And so we have K plus and NO3 minus. And our net ionic equation, I like swapping the H, I like my H to go first, but you can put the OH first, it's okay. I like the H to go first because it just makes more sense in my head. I don't know, doesn't matter. You could have written OH plus H, yes? I usually like to write my cation first and my anion second, but it doesn't matter. Your choice. H2O, liquid. So reminder, our net ionic equation, all we have to do is take our complete ionic equation and cancel out the spectator ions and we get our net, okay? Do we want to do another acid or do we feel okay? Another acid? Okay, let's see if there's a nasty one here. Oh, look, number 6 is nasty. Shall we do number 6 together? Okay. We have AlOH3 aqueous plus H2SO4. Combine our outside ions. Combine our inside ions. So we have Al, which is 3 plus, and SO4, which is 2 minus. So that's going to be Al 2 SO4 3 plus, who's our other product? Water, H2O. You can write HOH if you like.
Like, you have to, like, for these, we have to, like, balance it,
We'll get to that, okay? Now, we have to balance this because we're not balanced. And if you remember, balance your most complicated compound first. We've got 2 ALs, so let's put a 2 here. And we've got 3 SO4s, so let's put a 3 here. And if I have 6 OHs, how many waters will I make? 6 waters. I also have 6 H's, which again makes 6 waters. Complete ionic equation. You always have to consider both the coefficient and the subscript. So coefficient and subscript. So for aluminum, we have 2 ALs. So just 2 AL, aqueous, plus how many OHs? 2 OHs? 6 OHs. How many H's? 6 H's. I'm supposed to what? What did I forget? I forgot my charges. It should be 2Al 3 plus. Okay, good. I got 6H plus. What else have I got here? 3 SO4s. Not 12 SO4s, right? 3 SO4s. Huh? Talk loud. You need states. Yes. Did I forget states? I will do this frequently because so many people forget both their charges and their states. So I want you all over it. I want you to be like, Miss Spence, you forgot your charges, you forgot your states. All right, so those are our reactants, our products. Oh, what did I forget upstairs? I forgot what did I forget in my formula equation? States. Oh, is that a solid or is that aqueous? I would have to look that up, wouldn't I? SO4, it's aqueous? I thought so. Aqueous. So we have 2 aluminums. And we have 3 sulfates. And what do we do with water? Do we split it apart or leave it together? Leave it together because it is a liquid. Yes. States. Okay. Aqueous, aqueous. Very good. Coefficients? Don't I have the coefficients? Oh, yes. I know. I need a coefficient there. Thank you. Thank you. I didn't even plan that one. What else we got? Charges. 3 plus, 2 minus. Okay, now we're good to go. Who are our spectator ions? Al, 3 plus, and who else? SO4, 2 minus. Yes? No, I don't put in the coefficients. Why not? Yes? Yeah, there's more than 2 ALs, which are spectator ions. There's not just 2 single ions. So never write the coefficients. Spectator ions, we don't need states. It's implied that they are aqueous, and we've written it up above. So yeah, you could if you wanted to. I mean, it wouldn't hurt, but you don't have to. And then finally, we need to write our overall reaction. Who's left? OH and H. So I have 6H plus aqueous plus 6OH minus aqueous gives 6H2O liquid. Yes. Can I cancel the 6s?
Oh, that's a good question.
It is a good question. The answer is yes. And you should.
So if you don't, it's wrong.
If you don't, you'll lose a half a mark. I screwed up.
What?
I separated my 2 H's from my SO4. It should have been H plus and HSO4 minus. Oh, well, you know what? Honestly, AP doesn't care. They'll take both. I've seen them. They take both in their key, in their answer key. They're like, it's okay. So we'll just be like, it's okay also for us. I know it does. It bothers me too. It bothers me as well. It does not make sense, Tony. I understand. So if we wanted to actually do it correctly, it should be 2Al 3 plus 6 OH minus goes to 3H plus, plus 3H plus, sorry, plus 3H plus 3H SO4 minus goes to 2Al 3 plus 3 SO4 2 minus plus 6 H2O. And if you're like, hey, what happened to that H? The OH just ripped it off. Which is why I think that AP is like, it's okay, close enough. I know, if you're sitting there, you're like, how did that happen? These OHs came along, and they not only reacted with these 3 H's, but they also ripped off those H's, because hydroxide is better at grabbing protons, H pluses, than anything else. So if you just want to stick with this for now, you can be like, yay, and I will not put H2SO4 on your quiz or test. Sound good? Yes.
So only HSO4 is the not so soluble.
It's not that it's not soluble, it's that it is weak. But you're also talking about the only 2 hydrogen strong acid. All the other strong acids only have 1 hydrogen. Okay, so it's not an issue for any of the others because their hydrogen comes off, there's no hydrogens left.
So it's just slightly different.
It's just slightly different.
So it's only worse with those acids that got 2 hydrogens.
Yes, but all other diprotic acids, which is how we call two hydrogen acids diprotic because they have two protons. All other diprotic acids are weak. So they would be together, 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 and then the OH rips the both of them off.
What about like H3PO4?
Okay, let's say H3PO4. Let's just do that over here. Let's do NaOH
It's a question up there.
plus H3PO4. Let's do this one because this is good. We should do this one. Is H3PO4 strong or weak? It is weak. Therefore, does it come apart or does it stay together? Stays together. So we have NaOH. Na gets together with PO4, Na3PO4, aqueous, plus HOH gives us water, H2O, liquid. And then for balancing, we need 3 sodiums. That gives us 3 hydroxides, 3 hydrogens, which means how many waters? If you have 3 hydrogens, how many waters do you get? 3. Because every water contains 1 H and 1 OH, right? We got 3 H's. We got, oh, I'm sorry. No wonder you guys were looking at me puzzled. It has 3 OH's. There we go. That's better. Okay. Anyway, we need 3. I saw puzzled looks there. You should have been puzzled. NaOH does not contain H. It contains OH. I mean, it does contain H, but only within the OH. All right. So now this is balanced. Would we split the NaOH or keep it together? Split it. 3Na plus 3OH. States. Aqueous. Aqueous. Good. Charges. Plus, minus. H3PO4. Split or stay together? Stay together. H3PO4. Aqueous. Na3PO4, together or apart? Oh, did we get stuck? Tell your partner. Na3PO4, together or apart? It's ionic, it's aqueous, it should be apart. So 3Na plus 4PO. Oh, it's PO4. Okay, good. States and charges, aqueous, aqueous. Everybody, what's the charge of PO4? 3 minus. Sodium is plus. And we have, of course, H2O, together or apart? Together, 3H2O. Who are our spectator ions? Na and PO4. Here's Na. It stays the same from both sides. Here's PO4. Is PO4 staying the same? No. PO4 is not a spectator ion. It goes from being part of phosphoric acid to being split apart. Okay? So just Na plus. Yeah? And then our net ionic equation, our NIE, would be 3OH minus plus H3PO4. PO4 goes to PO4, 3 minus plus 3 H2O liquid. Is good? Oh yeah. Aqueous, aqueous, aqueous. Yes. Okay. Did we want to do an example from single replacement? Or do we just want to try that? Sure. Okay. Let's do it. Let's try. Let's try number 7. That looks exciting. What state would aluminum be? This is on page 89. That was when I graduated. So many years ago. Aluminum. What state? Solid. And if we are going to be reacting it with lead nitrate, does it make sense that we would be putting solid lead nitrate with a solid and having a reaction? No. What would we do with our lead nitrate so it can react with the aluminum? It's going to be aqueous. Okay. Who are our products? Well, let's first of all look and see if we do get a reaction. Aluminum and lead. Will aluminum replace lead? Yep, good stuff. So Al is 3 plus, so it's going to be Al NO3 3 aqueous plus PB. What state? Solid. Excellent. And these are actually pretty straightforward when it comes to the ionic equations. We have Al, which is a solid. We have, I didn't balance it. 2 here, 3 here, 3 here, 2 here. So we got a 2. PbNO32, do we take it apart or leave it together? Together or apart? Apart. It's ionic, it is aqueous, we take it apart. How many leads? 3. How many nitrates? Should I write the charge on Al? What's the charge of Al in the reactants? 0. How many nitrates? 6. Two aluminum. Six nitrates.
Wait, now you should write on part of Al, right?
Oh, should I? Okay. Yes. Yes, I should write a charge for Al because it is part of an ionic compound. Yep. And for lead, we shouldn't have a charge because here lead is 0. So no, we should not have a charge for lead. And states. Yes? Lead is a solid. Oh. Okay. So there we go. That is our reaction. Who are the spectators? Nitrate. Just nitrate. So do we feel okay about our single replacements? Okay. And one thing I'd like you to take note of here, what's the total positive charge on the left? 6 plus. And what's the charge on the right? 6 plus. Charge also has to balance. And it will, as long as you have balanced your equation. Yes?
For a double replacement, maybe not double replacement, maybe like these ones, these are like the charge on both sides is 0.
Yes.
But in this case, the charge on both sides is 6 plus.
Yes. As long as it's the same on both sides for the net ionic, it doesn't matter whether it ends up being 0 or not. And we sort of skimmed through double replacement yesterday. Would anyone like another example of that, or are we good to go? What do we think? Double replacement? You know what? I'm going to do one, but you can just ignore me because I know there were a couple people away. Okay, but if you want to just start working on 8.4a, 8.4b, and 8.4c, you can go ahead and do that. But I will do a double replacement just because I can. Okay. Just make sure I get something that works. Sulfate. Yeah. Okay, so here we have a double replacement where we have copper 1 sulfate. So that would be Cu2SO4. And it's a solution, so it is aqueous. And it is mixed with potassium chloride solution. Outside ions, CuCl, because it's copper 1 plus, CuCl. And K is positive, SO4 is 2 minus. So that's going to be K2SO4. And at this point, you have to say, do I get a reaction? So I will go and look on my data pages at my solubility chart. Copper 1 and chloride are low solubility, so we get a solid. So this is a solid. Potassium is an alkali. And all alkali salts are soluble. Balance this one. We've got a 2 coppers, which gives us 2 chloride, which means we need 2 Ks, but oh, we've got 2 Ks and we've got 1 SO4, so everything is good. That is our Fe, which stands for the formula equation. Now we're going to write the complete. Actually, I'm going to show you guys the shortcut first. So if you're at all interested in the shortcut to the net ionic equation, anyone remember the shortcut to the net ionic equation?
Talk about shortcut.
Yeah, I'm talking about the shortcut. Identify the precipitate. Yes, yes, yes.
Oh,
ID the PPT, which in this case is CuCl. Make that your product.
so it's just UCl2.
Cu2SO4 is copper 1 sulfate. It's copper 1, not copper 2. Yeah. So we're going to make CuCl our product. And your reactants will just be the ions you need to make that. So we would say, I need 1 Cu, and I need 1 Cl, and I'm done. So if you are asked only for the net ionic equation, you can do this shortcut. But you might be asked for the complete ionic equation. Yes. Yeah. And if you are asked for the complete ionic equation, you would do what we did in all our other instances. So our complete ionic equation, our CIE, we have an aqueous substance, so we split it apart. We've got 2 Cus, and we have 1 SO4. This one is aqueous, KCl is aqueous. So we have 2 K plus 2 Cl minus, and both of those are aqueous. We have a solid product. Solids stay together. So that would be 2 CuCl and K2SO4 is aqueous, so there would be 2 K pluses and SO4 2 minus. Who are the spectators? K. K does not change from side to side. SO4 also does not change from side to side. And you could cancel those out, and that would leave you with your net ionic equation, our NIE, which would be 2Cu plus aqueous plus 2Cl minus aqueous gives us 2CuCl solid. Are we done? Yes?
Should we not write the equations with the
Yeah, because all the coefficients for the net ionic equation are divisible by 2, we should cancel them out. Yes? And if you had like a 2 and a 6 and a 2, you would have a 1, 3, 1. Yeah? All right, so over the weekend, fun weekend, 8.4a, b, and c.
just the entire book of it?
Yeah, 8.4 b, 8.4 c. You can get, if you have extra time on top of that, you can get caught up on whatever dilution things you haven't done. We can save the big bad problem for Monday if you want to. Do you want to save the big bad problem for Monday? The biggest, baddest? Okay, so basically do this, get caught up on dilutions. And save the biggest, baddest for Monday. And Monday, if you have already taken your yellow atoms workbook, make sure you bring that with you, okay? Bring your atoms workbook on Monday. And also number your pages, okay?
That's wrong.
No, last time you don't need that one thing. I just want to make sure. Yeah. Okay, so this.
I got locked in.
So,
Yeah.
so, it's all, yeah, let's start at this. And the red one. And then the ending. Yes. It's like, if it's a strong, yes, and a strong base, it's okay. If it's acid, you're gonna have more stuff. Yeah, yeah. Acid is together. Yeah, what happens is that hydroxide preferentially, like this hydrogen is like I can be with C6H5COO, or I could be with hydroxide, and hydroxide is much stronger. And then it goes higher. Yeah, yeah. I essentially thought this little hydroxide is yeah. No, but you this is so that's like part of the same, right? Yes, we know. And then she's not the aftermarket. I don't know. It looks like it is. Oh, right. So basically, my plan over here is to make something with it. Well, it's page 87, you don't have to do. Cause it's just like review of stuff. That's kind of more like you can talk it all. Yeah. Yeah. Right. As long as you know how to. As long as you're like this. Yeah. There's content. Yes, of course. Or you think these are better, of course. I don't even remember anything about it. I just know that centrifugal is not a real force, but centrifugal force is. That's all I know. What's the centrifugal force? Okay,
Like this, such a usual. This is such a little because well, I'm sure. I think I should. Okay.
How are you gonna die?
Centrifugal was.
She said, "No, it's like,
If you like that,
and so.
he was for real, like people, like,
I can't remember.
I'll go look.
Not there.
yeah, it was like,
Okay. I know this portion. That's such a little bonus.
I don't even know how. I don't know how. I don't know how.
like, marked it as correct, but then it was wrong. And then John decided to do like a good first. Yeah. Yeah, they changed that and John lost. I hope really, like, more
Versus.
Yeah.
Stop.
and then a lot of like. It's like. You look at no, but technically, right? It's just all the all I really like that. Wait, what?
Last year.
Am I stupid? Okay, yeah.
Oh, disgusting.
Yeah, usually. It's like. Wait, I makes it larger though. Wait, what?
Yeah.
Yeah. I'm actually. Yeah. Yeah. So it was run by the province. No reaction. No, stop, no shoes. Yeah, no, but I think about it.
So apparently, we are missing the answer key for 9 through 14. So I'm going to see if I have it kicking around, and we've got like what, 2 minutes? I'll print it out if we have time.